So in case you haven't gathered already, there were twin objectives in this project. One was to build a framework which we could use to provide instructional outlines or learning courseware for lots of different topics. This one being linked data, because linked data is complicated. People just don't, it's like speaking a completely foreign language, and since you don't know where to start, it seemed like putting together something that was of this sort would be helpful to people. And then whether you were doing open linked data or just linked data, you'd be able to figure out how this stuff works without having to get totally immersed. And you can skip around as these two are showing. I think David's done a gorgeous job on the website, and Marcia's been among the lead to collect all those resources. And we are looking for additional resources to add to this. So whenever you have them, let one of us know. So this is who I am. What I want to talk about then is this whole concept of taking the triples and linked data and putting things together, because many publishers have a great deal of their data stored in XML, whichever kind of XML they choose, JATS or .book or something else, EPUB and so forth. And the idea is that you're going to display it, but it's not optimal for searching. So we're looking for something that might give us a different format and allow different kinds of relationships so that searching can be leveraged. So in structuring that data, there's no time on here. Sorry. I'm cognizant that I'm the third speaker and we have a short session, so I don't want to go over. So what we have is one of the ways to structure our data for searching is in this thing called triples. And the triples are talked about a lot, but what I want to talk about is how to actually parlay that into something that you can use. I know there's some people in the audience who've done triple stores, but not all that many. There are other things besides the Sparkle query. Sparkle is the most popular one, but Star and Apache and others have triple architecture to expand search. But normally there's a subject, a predicate, and an object. They always say subject, object, predicate, but it's actually the predicate that connects the object to the subject. So if we say John Smith lives in New York, we might be able to infer, and we know that New York is in the United States, then we can infer that John Smith lives in the United States. The problem is that we can get multiple instances, and we can get a lot of recursive loops. So here's an example of Ben Franklin, and I think you've probably mostly seen how these things work, but he was a postmaster, he was an ambassador, he lived in Boston, but he also lived in Philadelphia. He invented bifocals and did a lot of things. So we can connect the things that he did and then add a few other connectors, like the postmaster is a job and so on, and we suddenly get a good web of information, a lot of connectivity. But what about if we want to extract for triples and get that data organized so that we can really leverage it? And this is the trick, and this is where we need to learn about how this stuff is put together. So with luck, your data is already normalized. You might be using a series of IDs that will be helpful. You might be indexing from a controlled vocabulary or taxonomy. You might have an author and institution name file that's normalized, but a lot of people don't have that. So then we also might have maps back and forth to the data. So you might map an author name to an ORCID, which is increasingly available. You might map your data, author and affiliations data to Ringgold, which is ever better data. And you might have a DOI citation that you've registered with Crossref, for example. So then once you have that data connected in some way, you can extend it to any document type. So it doesn't matter if it's journal articles or patents or organizations or any kind of information object, they can all be auto-connected. What you see a lot is this graph of the linked open data cloud. But for most publishers, they might want to leverage some of the open resources, but what they're really interested in leveraging is their own content. So looking into the linked open data options, but trying to keep it so that your own data is leveraged, you can use exactly the same techniques. So having paid attention to the linked open data cloud and the whole notion that Tim Berners-Lee had about how this how this might work, I still have that typo. So we've been, sorry, I know this is a publishing meeting and I have a typo. So people will use an HTTP link it or a URI so that people can look up names and link to them. And you can link to data outside, or you can just link to things that are inside your own organization. And one of the things that we've looked at and connected to in the platform that's already been displayed and discussed is how those design issues happen for linked data. So that kind of stuff is connected in the learning tool that we described. So what we need to do is connect your data and decide what you need to connect it to, what of those will be inside links and what will be outside links. And you can choose to connect to both, which is the more likely implementation. So, and here's an example of how that works. So somebody has an XML record, as you see on the left, and some different kinds of triples that you could build, maybe for DOIs and for authors, standards, institutions, and so forth, and maybe linking to external data sets, but certainly data sets outside of the database you're working within. So they might be inside your server cluster, but external to the triple store itself. And you might also go outside to verify that data out of Crossref. Your thesaurus might be inside. You might have downloaded ORCID IDs internally and so on. So you can do a lot of things leveraging both sides and be much more powerful. Well, if you want to do it just inside, you're linking to your own data sets, but you're using exactly the same architecture. So whether it's inside your cluster or outside, you might build a list of people who have received a Fellows Award or somebody who is in your author authority file, or you might have assigned subject expertise to your internal peer of reviewers and editors or even the members, and tag all that data so that you can leverage it for yourself. If you look at some of the big outside triple stores that have been created, BBC is one of the archetypical ones that's publicly available. They used linked data and they create customized web pages on the fly depending on what people are interested in. So they're not spending as much time with a huge team of web developers to vend all the content that they have, but rather building it based on this rich resource that they have interconnected internally. It's able to pull up live and immediately tagged as it streams through the BBC, and it removes that challenge of trying to keep the database up to date internally because so much of it is automated and it's quickly built. So for an individual publisher, your system might look something like this. You're building on all these basic and well-known now, or at least well-established systems like the Universal Resource Locator, Unicode, XML, maybe with some namespaces and certainly with a schema or a DTD, using the RDF syntax and an accompanying schema, and then maybe OWL or some kind of a published ontology. The Dublin Core, of course, to us was interesting because it forms an excellent guideline. It's not still, to my mind, a standard, but it's an excellent guideline to how data should be tied together. The friend of a friend options so that you can link people back and forth. And then, of course, you might decide that you want to have individual activities or events, everything from publishing a journal article to a new conference that you're offering, or the issue of a new bit of news to people. All of those kinds of things can be tied together. You can use SCOS as an export for the controlled lists, or you can just go with a full OWL. So what do they look like? So here's some sample ontology classes that we're going to use in building this linked data set. We might have some kind of a thing, which is what this very important, I could have used stuff, but thing sounded better. And this item might have a right statement. It might have an actual physical document or digital document attached to it. It'll have a collection ID, some item like could be an edited book. We could have a journal volume or an issue. We can have all kinds of different things that are linked to one data type. So we're taking this and we're translating it into something that looks more like this, so we have an idea of translating the data so that it can be read by the computer in the syntax for the triple stores. I promise I don't have very many really techie slides. So what people are doing now is we built the LD4PE, which now that it's 4 years later, we kind of think, well, maybe we should have named it something a little less in-crowdy, because LD4PE is not rolling off the tongue. But it does provide a platform not only for people that are teaching linked data and all of the associated things, but also a place to contribute and a place for people to learn directly and on their own. For scholarly publishers, if you harvest author information and you add additional affiliation information and then you link to external data sets, you're really already there. So for example, you can take a thesaurus or a taxonomy, some kind of a synonymy, and auto tag the data. You could also, and then the data doesn't have to be just journal articles, but could be any number of other things like awardees or fellows or some kind of people. It could be events, could be any kind of things. And then you can apply the triples statements to them across the corpus. And it gives you a good way to analyze what you're missing. It also gives you a good idea of a way to look for trends. So in this particular case study, what we have is that doesn't work. We have the document here. Down here we have the name of awardees as an authority file, and over here we have fellows authority files. So we have the fellows, we have the awardees, and we have the documents about them. So this sweet spot gives us all kinds of additional information about people in the database, and it might, from the original document, give us address information, from the awards and fellows information about what kind of a person they are. So we get a lot of information that forms a good, solid, and quick interchange, and if any one of those things happens, it's going to be able to update that record in that intersection. So you don't have to make that link, it's automatically updated for you. So those external resources, there's so much information out there in linked data, and it's so obtuse that people just don't know where to go. And our hope is that people will be able to mine this and find what is of most interest to them, get the information that's most useful, find out where it's stored, and for your own data, they'll be able to find the nuggets that they've been looking for. So the end result is that by extracting all that information from journal articles along with all the other information, we've created a really rich data environment. And you have concept, you have content, you have authors, you have references, everything's linked together into a single repository that's interconnected. And the resulting structure might give you graph databases like Sparkle and endpoints, but it would also work within a Lucene search engine, for example. So it's incredibly versatile. And then your data is available to become part of a larger web of information, whether it's just local or whether you decide to put it out there globally. And that's it. So